unsafe property conditions, we are here to provide support and legal representation at no cost to you. Call us today at 713-221-3773.
The best bilingual news, business talk, and technology content 24 hours a day, 7 days a week. You are watching Now Media.
For decades now, our planetary science news cycles have been dominated by Mars. The red planet is populated solely by working and a few not working robots, starting with Sojourner through to Spirit and Opportunity and on to Curiosity and Perseverance, along with a little drone named Ingenuity. We've covered launches, landings, lifespans, endings, and science results, which is great. Mars is relatively close, and we had a lot of experience landing there and science goals to pursue. But all of our work at Mars has left our closest neighbor, Venus, off the mission list. That is until 2021, when NASA and the European Space Agency announced 3 separate complementary missions to that hellscape world. For NASA, the 2 missions were Da Vinci and Veritas, and each was given a $500 million budget to develop and plan, with an expected launch in the time frame of 2028 to 2030. And now, one of those missions, Veritas, is threatened to be completely mothballed before even really beginning. Later on in the show, Beth Johnson will interview Deputy Principal Investigator Darby Dyer about why Veritas is suddenly on the chopping block, what this means for planetary exploration, and how the public can help change NASA's mind. In addition to news from Venus, and also Mars, to be honest, we have stories of explosions and mergers at the galactic level, and aerospace correspondent Eric Mattis will be here bringing us news on what went up and who is going up in the future. All this and more is coming to you right now on Escape Velocity Space News. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. I'm a nerd. I'm the kind of nerd that doesn't always keep up on all the newest slang. When I heard folks calling Simone Biles the GOAT during the last Olympics, I was really concerned about it being some new slur. But no, it was just the word used to celebrate her reign as the greatest of all time. Since then, numerous people have been called the GOATs of their field, and this phrase has reached a level of popularity where we are now seeing astronomers adapting this phrase to our weird little field of science. I would like to introduce you to Gamma Ray Burst GRB 221009A. It is the boat, or the brightest of all time. This chuckle-worthy descriptor was shared out as part of the title in a new paper led by Eric Burns and appearing in the Astrophysical Journal Letters. GRB 221009A is the catalog number for a long-duration gamma-ray burst that went off on October 9th, 2022. Initially detected by Swift and Fermi orbiting observatories, this explosion marked the end of life for a massive star. The exact details on what causes some but not all supernovae to generate several second to several minute long gamma ray bursts isn't fully understood, but theories range from the core of the massive star collapsing into a jet-producing black hole to the massive star exploding in a binary system and the jets being created through interactions between the primary star and its companion. Along with detecting the initial explosion, Fermi also observed the expansion of X-ray rings away from the burst, and the optical afterglow was even visible in the kinds of consumer telescopes a lot of amateur astronomers use. If you'd like to see the remnants of this event today, the hot spot still glows in radio light. Located just 2.4 billion light years away, the rain of high-energy light from this event affected Earth in ways I honestly didn't know was possible. Lightning detectors in India and Germany observed the Earth's upper atmosphere being mildly affected, and a large influx of ionized particles were also detected. Now, before you start asking, what would happen if this kind of an event happened here? I want to assure you that GRB 221009A is considered a once-in-10,000-year event. So you don't want to know what would happen, but you also don't need to worry. If you'd really like to worry, I recommend Phil Plate's book, Death from the Skies, and its chapter on gamma ray bursts. Death from the Skies isn't just a good title from a book. It is also a good way of describing past and potentially future events here on Earth. We actually think that a gamma ray burst may have caused a mass extinction 440 million years ago, right here on Earth. And in the future, we need to be aware that all manner of terrible and beautiful things have the potential to happen given a long enough period of time. One of the probably less deadly and more beautiful future events is the predicted merger of our Milky Way galaxy with the nearby Andromeda galaxy. In about 5.5 billion years, our two galaxies will lose their current shapes as they merge into a new, larger galaxy. When this happens, the black holes in the galaxy centers will inevitably become active as material is driven into the centers of the systems. This kind of a merger is something we can see happening throughout the sky, but it was much more common earlier in the universe, and the results were far more dramatic than the kinds of events we see today. Basically, the universe had more galaxies with opportunities to merge, and those galaxies had more gas and dust available to light things up. In a new paper appearing in the journal Nature and led by Yuxing Shen, researchers discuss a newly discovered merging pair of galaxies with actively feeding central supermassive black holes that are just 10,000 light years apart. The light from this system has been traveling toward us since the universe was just 3 billion years old. Observing supermassive black holes this close together at this large of a distance was a task for some of the best and largest telescopes above and on this planet. The Hubble Space Telescope was the first system to spot these two closely aligned pinpoints of light. The European Space Agency's Gaia Orbiting Observatory was then able to confirm the kinds of brightness variations that are common in quasars, and follow-up observations by the massive Gemini North Telescope with its 8.1-meter mirror were used to confirm the two pinpoints were quasars at the same distance. With an initial confirmation in hand, or at least on hard drives, researchers were able to get time on the Very Large Array, Keck Observatory, and Chandra X-ray Observatory to aid in further confirming this system's dual identity. Astronomers have to be extra careful to verify what's going on when they find two similar objects not too far apart on the sky. This is because gravity is the OG creator of deepfakes. The gravitational pull of truly massive objects has the ability to bend light otherwise destined for other parts of our galaxy and actually bend it toward us. In some cases, this can twist a background galaxy into a ring or replicate it into multiple blobs of light that each look a little bit different. Exactly how light gets bent is described very precisely by the mass and distribution of the light-bending object. Normally, astronomers are able to model the gravitational lens using standard galaxies with a fairly standard ratio of stars, gas, dark matter, and of course a supermassive black hole. One system, however, refused to match. In a galaxy cluster of Bell 1201, a streak of light could only be explained by a galaxy with what they are terming an ultra-massive black hole, with a mass of 32.7 billion solar masses. This object is nearly 10,000 times more massive than the merely supermassive black hole in our own galaxy. With ultra mass comes ultra light bending responsibilities, and this black hole has used its powers for the good of science. After the break, we're going to look at more amazing science. But this time, we're going to stay a little closer to home and look at worlds within our solar system. Stay tuned. One of the weird truths about studying planets is that we often can't get a good full planet view without getting far, far away from the planet. Our best views of Earth have come from cameras at the moon. We monitor Mars for dust storms using telescopes right here on Earth. And when it comes to watching the outer planets, the Hubble Space Telescope has been our erstwhile observer since 2014. That year, the Hubble Space Telescope began its Outer Planet Atmospheres Legacy Program, or OPAL. And for the past 9 years, HST has been taking yearly observations of far-off giants. In February, we got our 2023 image of Saturn, and at the end of March, new images of Jupiter and Uranus made their way to the NASA website. Besides being shockingly beautiful, these images also allow us to see how the worlds are changing over time. For instance, Jupiter's Great Red Spot is still big enough to swallow Earth, while also being the smallest it's ever been. Over at Uranus, we see the planet's weather changing as the world slowly rotates its pole toward the sun. Storms are building as the pole heats up. In 2028, Uranus will point its pole directly toward the sun. And if it lives long enough, that will be HST's first time seeing that kind of alignment since its 1990 launch, which occurred just a few years after Uranus's other pole pointed our way. And as for Saturn, besides seeing the banding becoming more distinct as the ringed world heads towards equinox, we're also seeing the rings more and more edge on. Right now, this is the angle I have to admit I like best. We don't really know how long HST will be able to keep going, but it is currently hoped it will continue doing science through the 2020s. For hopefully the next few to many years, we will be able to work with Hubble's optical and ultraviolet images while collecting longer wavelength infrared images with the new JWST. Giving us a hint at what is going to be possible, JWST released its own image of Uranus, allowing us to get an even more dramatic image of Uranus and its rings and storms. But as amazing as this image is, I have to say it leaves me a little bit sad. I'm a Gen Xer, and my childhood was punctuated by images from the Voyager 1 and 2 missions. And Voyager 2's 1986 image is still the best image we have of this ice giant. When your best image is heading towards 40, it's time to plan a new mission with new technology so we can update our understanding. Unfortunately, while missions to the icy giants Uranus and Neptune have been finalists in various mission selection rounds, none of those missions have been picked. Here's to hoping images like these help highlight how much science really requires a camera to get up close and personal. While the ice giants have been basically left alone, the robot population on Mars has been regularly increasing through the years. And NASA's newest Mars rover, Perseverance, celebrated its 749th Martian day, or SOL, by sampling a rock from a new region of Jezero crater. On March 30th, Percy etched a circular pattern and drilled a rock sample from a rock named Berea. This is the 16th sample Percy has collected. This particular sedimentary rock is thought to have formed as an ancient river deposited grains of material. Rocks not too different from this can be seen in former river deltas on Earth. This particular rock is also made of the same kinds of carbon-rich minerals that often contain fossils on Earth. If we are going to find signs of past life on Mars, this is the exact kind of rock we need to be sampling. And this rock, Berea, welcomes Percy into a new stage of exploration. Back in the summer of 2021, Percy explored the flat crater floor and the igneous rocks that formed from once molten rock. Over time, this little rover has climbed through the crater, and its samples transitioned from igneous rock to sedimentary rock made of fine particles. Now we're getting into the coarser material, and with this change in geology, there are certain to be new and exciting updates to our understanding of Mars. As those discoveries are made, we'll bring them to you right here on EVSN. From the outer solar system, I'd now like to take a moment to look inwards towards Venus. Located about 30% closer to the sun than Earth, a runaway greenhouse effect has superheated this planet to about 900 degrees Fahrenheit, which is about 475 degrees Celsius. First visited by Mariner 2 in 1962, this world has been visited by more spacecraft than any planet besides Earth, with missions both exploring it and using it to get a gravitational assist to other worlds in our solar system. Unfortunately, the bulk of the modern visits were just spacecraft passing through and getting a bump from Venus's gravity. But what data we do have keeps making it clear that Venus is one of the most dramatic worlds in our solar system. The Japanese Akatsuki mission settled into orbit around Venus in 2015 and has been using a variety of cameras to measure Venus's atmosphere at a variety of different heights. And in a new paper in Geophysical Research Letters, led by Takeshi Horachi, researchers describe gigantic vortices in the atmosphere of Venus. These storms appeared on August 25th, 2016, and then faded away, as storms will do. But when these vortices were present, they were bigger than anything so far seen on either Venus or here on Earth. How did they form? Don't know. This research paper is very much a look what we found paper that doesn't try to explain this new weather feature, which, to be honest, is totally fair. Weather happens on Earth that we can't totally explain, and Venus's weather is a whole lot harder to study. What this paper tells us is that Venus has really cool vortices that come and go, and that is just kind of awesome. And I can't wait to see what we're able to see in future papers from the Akatsuki mission and its science team. We have one mission at Venus right now. Others visit repeatedly, like Parker Solar Probe. But there's only one mission dedicated to studying Venus at this moment. But a lot of us are really hoping that will change. For me, I want missions to go there so we can look for modern-day volcanism and work toward understanding just what terrible thing caused Venus to go from a watery world not too different from Earth to the acid-raining deathscape we see today. This is science that can't be done by Japan's mission. The best we can do is reprocessed data from the Magellan mission, which orbited Venus from 1990 to 1994. Modern software and modeling techniques allow us to do more than was possible back in the days of Windows 3.1, and the discoveries being made include a new map of approximately 85,000 volcanic edifices, as well as magma fields. While the majority of these volcanoes are less than 5 kilometers in size and are comparable to what we're used to seeing here on Earth, there are also volcanoes more than 100 kilometers in size, including Sapus Mons, a 400-kilometer diameter volcano that would easily sprawl from St. Louis to Indianapolis. This kind of volcanic history is only rivaled by Jupiter's moon Io, and that moon is getting constantly stretched and squeezed by the gravity of Jupiter. A couple of episodes back, we shared with you the discovery of an active volcano on Venus that erupted while Magellan was orbiting. We don't know how many of these 85,000 volcanic edifices are still active. To find that out, we need new missions to Venus that can look through the clouds with radar or send probes down or both. And we need those things to tell us with modern instruments what Venus is doing today. In the next segment, my colleague Beth Johnson is going to interview Veritas Deputy Principal Investigator, Darby Dyer. In 2021, the Veritas mission was selected by NASA to build that next radar mission to Venus, and to actually do a lot more than just radar map this volcanic world. Right now, Veritas is on hold due to issues with the Psyche mission and JPL. Exactly what this means, Dyer is here to tell us. Stay tuned.
Back in June 2021, which seems like half a decade ago at this point, NASA announced the selection of 2 missions to study Venus. Each mission was awarded approximately $500 million and expected to launch in the 2028-2030 timeframe. And then things changed. Joining me now to talk about one of those missions and its current challenges is Dr. Darby Dyer, Deputy Principal Investigator for the Veritas mission. Thank you for joining us today.
Oh, I'm happy to be here. Always happy to talk about Venus and Veritas.
So let's start at the beginning. Why Venus?
Why Venus? Well, when I was a graduate student back in the 1980s, back in the dark ages, there was a mission proposed to Venus which was canceled, and then they literally assembled some of the old spare parts that they found and came up with this mission called Magellan, which ended in 1994 and which was revolutionary in changing our understanding about Venus and the surface processes that might happen there. For example, the Magellan mission found that the entire surface of Venus was remarkably young with very few and randomly distributed craters, which led to many, many questions about how Venus formed and what its geological processes are. But in the last 30 years, even though the community has repeatedly posed missions to Venus, it wasn't until, as you said, last year, 2020, it wasn't until last year that NASA finally selected 2 missions to Venus that will go back and answer some of the questions that the Magellan mission some 30 years ago left us with. So why Venus? Why now? Well, there's growing recognition now that Venus is a very typical exoplanet. In fact, about half of the exoplanet discoveries are actually Venus-sized planets. And so by studying Venus, we get a glimpse into what the other exoplanets are elsewhere in our universe, which is a very important thing. The other thing that I always tell people about why Venus now is that there's growing recognition based on the data that we do have that Venus probably had liquid water, for about 3 billion years. In fact, as the solar system evolved at the beginning and the sun heated up, Venus probably had liquid water and oceans before Earth did. And so Venus has gone through this whole cycle of 3 billion years of liquid water and oceans. And in my book, that's the great recipe for developing life. So unlike Mars, which only had liquid water on the surface for 300 million years, Venus's 3 billion years, I believe, gave us ample time for life to potentially have arisen. So to me, these two things, the fact that Venus is very much like an exoplanet and the recent work that suggests that Venus had liquid water for so long, really make it the ideal target in our solar system to follow the water and look at places where life could have begun. So that's why Venus now.
Speaking of life, and just sort of as an aside, do you feel that the supposed discovery of phosphine in the atmosphere of Venus had a huge impact on making this decision to do not one but two missions to Venus?
I think that the phosphine, I was going to call it a debacle. The confusion over phosphine certainly got the community, the planetary science community, broadly interested in what was happening in Venus. But I think there were doubts about phosphine from the beginning, and therefore I don't think that necessarily helped our cause. The thing that did help our cause, of course, is the recent discovery of active volcanism on the surface of Venus. I'm sure you've read the paper by Herrick and Hensley. It's amazing that they were able to excavate out of 30-year-old data that was very low resolution, a crater that has changed, or that changed between 3 different cycles of the Magellan mission. That just blows your mind. So to me, that's the thing that's changed. Of course, that was post-decision, but now the excitement over the existence of active volcanism on Venus carries over into us wanting to get Veritas to the Venus surface as soon as we possibly can.
All right, that brings me to the missions themselves. So, what is the Veritas mission?
So, the Veritas mission is composed of 3 different sets of experiments. The first one is a radar, which will enable us to do topography and create an elevation model of the surface of Venus. The second one is a spectrometer, which will let us look through the clouds of Venus and determine something about the composition of the surface, which has never been done before. Particularly important in my mind because we have no idea what the rock type is on Venus other than really speculation and pictures. And then we will also do a gravity experiment, which data we will use to constrain the core size and state of Venus, which is another sort of fundamental parameter about a planet that we don't know for Venus. So it's those 3 experiments, a radar, a spectrometer, and a gravity experiment that compose.
And you are the co-lead on one of these?
I am actually the U.S. co-lead on the spectrometer. So if I sound a little biased, that's because I'm a spectroscopist and I love to talk about spectroscopy on Venus.
So what sorts of information are we hoping to learn from these different scientific instruments and mission? What's the goals of the mission here?
The goal of the mission is to actually answer an ambitious, large number of science questions that all relate to the evolution of the geology on Venus. So we're interested, for example, in continuing our work on change detection and active volcanism on Venus. We want to make a topographic map that will be 20 times higher resolution than the Magellan mission 30 years ago. As I said, we want to understand the core size and state. We're looking for evidence for plate tectonics. We'll do some interferometry, which will help us identify places where there might be subduction zones. Let's see, we'll be able to see smaller scale craters than we were able to see with the Magellan mission. So there's a whole array of science goals on Venus that we'd like to accomplish with the Veritas mission, and they're all aimed at making a global, having a global understanding of what's happening on the surface. And this is something that Veritas is uniquely able to do of all the missions that are currently either planned or in progress on Venus.
That brings me to the fact that there are 2 of these missions. What is the difference between your mission and the other mission, Da Vinci Plus?
So the missions are they're complementary. They don't really overlap very much. So while Veritas is focused on fundamental global coverage, so sort of the underpinnings of all future exploration on Venus will come from Veritas. So a good topographic map, so we'll know where to land. Rock compositions, so we'll know where the interesting contacts are on Venus. On the other hand, Da Vinci is focused more on the atmosphere, and in particular, they're hoping to look at the noble gas composition and the isotopic composition of the atmosphere. And as their profiler descends, they will look at the changes in gases and isotopes as the probe descends. And then if they're lucky, they will also get pictures from below the atmosphere and possibly even survive landing. It's not a guarantee for Da Vinci, but if they do survive landing, they might get some amazing images. So the two missions are complementary. Veritas is the fundamental data sets. We'll produce terabytes of data, which will last for decades if we don't seem to get another Venus mission anytime soon. Da Vinci is more of a very focused investigation that really is all around the question of what is the composition of the Venus atmosphere as a function of height above the surface, and what does that tell us about the history of water on Venus. So the two missions, in some ways, we're both looking at the same kinds of questions, all related to water, right? Veritas wants to know, does Venus have continents? If so, did the continents form in the presence of water? Are the old terrains on Venus, which are called tessera, are they indicative? Are the old terrains on Venus indicative of a time when Venus once had water? We'll also be able to look at water vapor. If we happen to see active volcanism when we're in orbit, we can actually detect that with our spectrometer. Whereas Da Vinci is just going to be more of a snapshot of this, of what the probe sees as it goes through the atmosphere.
All right, that brings us now to the big topic here today. So the two missions were scheduled to launch in the 2028-2030 timeframe. Along came the mission to Psyche, and what has happened that mission and its review has had an impact on Veritas?
So last November, there was an institutional review board review of the Psyche mission, and this followed the fact that Psyche had announced that they were going to have to delay their launch by some period of time, roughly 1 year. And in the process of that review board investigation, it was found that there were some apparent management problems and staffing problems at the Jet Propulsion Lab. And therefore, the postponement was going to have to happen, and it was going to cost NASA extra money. And so very soon after the IRB report, it was announced that the Veritas mission would be stood down. And the only funding remaining for Veritas would be about $1.5 million a year for the next 5 years to support the science team. So this came as a huge surprise to the Veritas team. It came as a huge surprise to the foreign partners who are putting up about $90 million for the Veritas mission. So it was quite a traumatic event, I can tell you. In particular, the review board called out 5 areas of the Jet Propulsion Lab that needed to be dealt with before before NASA would give JPL the go-ahead to try to proceed with Veritas. And intriguingly, 4 of those 5 areas on Veritas are not even being handled by JPL. They're being handled at Lockheed Martin. So there's been a lot of confusion in this decision about what the justification was. But we're happy to kind of put that behind us. The Psyche Review Board is meeting again this week. It looks like everything is on schedule. JPL has made some significant management changes, which, while they won't affect Veritas, will hopefully satisfy the conditions that headquarters placed on us and on Psyche and allow us to move forward. Now, the other issue related to this is that, as you noted, at the time of selection, there was $500 million for each of the missions in the budget. And now, magically, 18 months later, the money for Veritas is gone, and headquarters has said on repeated public appearances that there is no money for Veritas. So that's very sad also. We have gone back to headquarters in January of this year, we presented a bridge funding budget to headquarters, and it was a very small budget, tens of millions for the next 2 years, just to allow us to continue to work with our foreign partners and make sure that the things that the foreign partners are doing will continue to be supported by engineers at JPL. And that request that we made in January was turned down. So since then, there's been a great deal of support that's come to Veritas from the planetary science community. In fact, a group of the advisory group chairs came together and came up with the recommendation that asked headquarters to not consider another solicitation for the Discovery program until Veritas was funded and able to fly. So I'm touched and pleased by the fact that the entire community supports us. Of course, the entire community is also worried that this could happen to them, because if a selected mission can be stood down at any given time, then this may apply. If this is a precedent, then it may not only apply to Veritas, but to other future missions. So I think the community is speaking loud and unanimously in saying that headquarters shouldn't do this. The competition process should be robust, and a selected mission should be prioritized before additional competitions are made.
The scientific community has definitely been very vocal. There's the hashtag on social media is Save Veritas. And I noticed that there seems to be some options where the public can possibly help bring this back to NASA's attention. What can people do to help you get this mission off the ground?
So pressure members of Congress, that's what we're looking for. We're looking for either an appropriation or a change in the authorization language that would promote launching Veritas in 2029. And if you want to be part of that petition, all you have to do is go to planetary.org and go to their Action Center. And the first thing on the Action Center tab is a petition for Veritas. And all you have to do is put in your name and address, and it automatically figures out who your members of Congress are and sends them an email. So it's a painless way to really make a difference and help us convince members of Congress that Veritas, which is sort of a broken promise to the scientific community, that this promise gets rectified.
Well, Darby, as a journalist, I know I'm supposed to remain unbiased. As a planetary scientist myself, I am definitely not unbiased in this. And I do encourage people to please contact your legislators if you're in the United States. Please talk to them. Please help us get this mission back off the ground. This is important science, and I would really like to personally see it happen. Obviously, there are careers and employment that are at stake, and there is a lot of stuff going on here that I think that as the public we should not only just be aware of, but be active in. So, Darby, thank you for being here. Thank you for talking about this. Usually when I say good luck, I mean in, getting the actual mission off the ground, doing the launch, all of that stuff. In this case, I mean really, truly good luck. Our thoughts are with you, and we'll definitely be encouraging people to support this as best they can. So thank you for being here today to talk to us about it.
And thank you to everyone who goes and fills out that petition. It really makes a difference. So thanks for listening.
As we've said on more than one occasion on our show, space is hard. Usually we're referring to the challenges of successfully launching a rocket and getting to orbit. Rockets are complex machines that are very unforgiving to something being even slightly out of spec. But there's another part of space that can be hard on companies at times, the business of space. Over the years, there have been numerous companies that have entered the space industry. Many of them are large aerospace companies that operate in both the civilian and military sectors. So they were able to leverage their experience to expand into the space sector. Over the last couple of decades, however, we've seen numerous companies entering the space sector from scratch, as it were. These new entrants have tended to be smaller companies that haven't had any presence in the aerospace sector. Often they use a design process that features rapid iterations in development as opposed to the more traditional approaches often used by the well-established large aerospace companies that see an entire design completed and built once over a generally longer period of time. Unfortunately, the space industry is an expensive sector in which to conduct business. Failures are part of any development process. However, in the space sector, failures can be really expensive, even if the failures can be learned from in the process. If a company has too many failures or not enough successes or not enough customers or any of a number of other things, the company can experience extreme financial difficulties leading to its demise. Recently, Virgin Orbit, one of Richard Branson's companies, filed for bankruptcy protection. Virgin Orbit was spun off from Virgin Galactic, the space tourism company, about 6 years ago to provide launch services to orbit. Its fairly unique launch technique of dropping the rockets from the underside of a modified 747 means that it can offer launch services from virtually anywhere in the world that a 747 can operate out of. And they could do it on relatively short notice, which is of particular interest to military clients. They have about 50 launches under their belt since they started in 2017. Their most recent launch this past January was the 6th mission for the Launcher 1 rocket and the first rocket launch from Britain. Unfortunately, it failed shortly after launch, leading to the loss of the commercial and military research satellites on board. This, combined with the unrelated collapse of Silicon Valley Bank shortly thereafter, meant that finding new long-term funding became very difficult, and in March, the company had to suspend operations and lay off most of its employees. Based in Long Beach, California, Virgin Orbit had 750 employees, about 85% of which were laid off. The now former chief operating officer apologized to employees, saying that company leadership should have had more time to keep the company running. According to news reports, filing for Chapter 11 bankruptcy protection will allow Virgin Orbit enough time to find a buyer for the company. What does this mean for Virgin Orbit and its employees? That's a good question. It could end up that the company finds a buyer that wants to continue operating the company, which could see many of the employees who were laid off recalled to work, assuming that they haven't found new jobs by then. Another possibility is that they are absorbed by another company and some of their technology continues on, but under a different name and with different people. Or the company could be dismantled and the assets sold to repay the creditors, or there could be some other option. Only time will tell which comes to pass. This goes to remind us all that space is hard in many different ways. And speaking of spacecraft, next up, I'm pleased to welcome on aerospace correspondent Eric Mattis for this week's Tales from the Launchpad. Hey, Eric.
Hey, Pamela. On April 2nd, a Falcon 9 lifted off from Vandenberg Space Force Base, carrying 10 satellites for a new constellation for the Space Force called the Tracking and Transport Layer. The launch had been delayed several days due to a problem with one of the 9 engines on the Falcon 9's first stage. At the time of recording, it remains unclear exactly which of the several types of satellites under contract for this constellation were on this mission. However, we know there were 10 in total, and SpaceX is one of the 3 possible satellite suppliers. SpaceX is building missile tracking satellites for the Space Force using the Starlink satellite bus and a sensor from another company. Up to 4 of those Starlink-based satellites could have been on this launch, or split between it and another launch expected later this year. The next orbital launch this week was a brand new rocket from one of the many Chinese private aerospace companies. This one was Space Pioneers and their Tianlong 2. The Tianlong 2 is a 2- or 3-stage liquid-fueled rocket capable of putting 1,500 kilograms into sun-synchronous orbit. The maiden launch of this new rocket on April 2nd was successful, making Space Pioneer the first private company to reach orbit with a liquid-fueled rocket on their first attempt. It was also the first privately developed kerosene and liquid oxygen rocket from China. These achievements are particularly impressive when you consider that Space Pioneer has only been in business since 2015, and as of 2 years ago, they were still working on solid-fueled rockets. On April 7th, SpaceX launched a commercial satellite, Intelsat 40E. A cool thing about this satellite in particular is that it hosts a NASA payload called Tempo, which will observe the Earth and track how pollution moves in the upper atmosphere. Intelsat 40E, for its part, will provide many different services for mobile connectivity for companies in the US. Among other things, this will allow better cell service in remote areas, on airplanes and boats, and for the government. To wrap up this week's rocket news, we have the launch of ESA's JUICE mission to Jupiter. This mission lifted off on the penultimate Ariane 5 rocket on the morning of April 13th. The Jupiter Icy Moons Explorer will take 8 years to reach its destination. Once there, it will investigate Jupiter's moons Europa, Callisto, and Ganymede. Its main goal is to determine if any of those moons could have, or did have, life. At a little over 6.3 metric tons, it's the largest spacecraft ever sent to the outer solar system. JUICE is expected to reach Jupiter in July 2031, and it will perform flybys of Europa in 2032 and of Callisto in late 2032 and 2033. With its investigations of Europa, JUICE will become humanity's first mission to visit an ocean world up close. The mission will then perform a braking maneuver to enter orbit around Ganymede, making it the first spacecraft ever to enter orbit around another planet's moon. It'll spend most of 2035 conducting a detailed survey of Ganymede from as close as 200 kilometers above the surface. JUICE will also explore Jupiter itself, looking for clues to its formation and how its intense environment shaped its moons, or vice versa. There was another Chinese launch in the past week, but we don't know much about it except that it was successful and it carried a classified payload on March 31st.
Before we go, I'd like to bring an upcoming launch to your attention. In general, we don't count our rockets before they ignite, but this one has the potential to be revolutionary. According to SpaceX, they are ready for their first orbital test of the new Starship, a massive booster, and the entire system all the way up to orbit. All they need now is permission from the FAA to perform this launch from Boca Chica, Texas. Rumor has it they are currently looking at no earlier than April 17. If you want to follow along with all the drama and suspense, the NASA Spaceflight YouTube channel is a great resource. They have cameras with multiple angles on the launch complex, and the commentators make watching a rocket frost over as it's filled seem exciting. I, for one, am going to be a tank watcher while we wait to see if this truly massive system succeeds on its first attempt. That's it for now. Good night, everyone. And remember, go out and look up.